In this unit, students are formally introduced to data analysis and statistics. They learn that a statistical question is one that can be answered by collecting data that are expected to vary. For example, what was a typical score on the math test is a statistical question, while what was Mateo's score on the math test is not a statistical question. Because the data collected to answer a statistical question are likely to vary, students use data displays to organize and make sense of the data. A display, like a dot plot, that orders the data and shows the frequency of each value can help students describe the distribution of the data. At first, they describe distributions using everyday language. Then they learn more precise vocabulary, like skewed and symmetric, to describe the overall shape of a distribution. And they use terms like gap, cluster, peak, and outlier to describe the features of a distribution. Students also learn to display data in a histogram by grouping the values into equal-sized intervals and then using a bar to show the frequency for each interval. They see that for some sets of data, especially large sets, a histogram is a good way to visualize the overall shape of the distribution. After describing data distributions with words, students learn how to summarize data using numbers. For example, they can use a measure of center to represent a typical value in a data set. One way to do this is to find the median of the data set. The median is the middle value, or the number halfway between two middle values, when the data are listed in order from least to greatest. Students see that the median separates a data set into two halves. The median of the lower half is called the lower quartile, or Q1, and the median of the upper half is called the upper quartile, or Q3. They use the median and quartiles together with the minimum and maximum values to make a box plot, which summarizes the variability of a data set visually. The length of each part of the plot shows how close together or spread out the data are in each quarter. Students can use a box plot to determine two measures of variability. The range is the difference between the maximum and minimum values, and the interquartile range, or IQR, is the difference between the upper and lower quartiles. The IQR represents the range of the middle half of the data. Next, students explore another measure of center, the mean, or average of a data set. One way they can understand the mean conceptually is as a fair share, or leveling out of the data values. The fair share interpretation can help them make sense of the algorithm for calculating the mean. Once students understand how to find the mean of a data set, they learn how to find a measure of variability associated with the mean. To do so, they first find the distance or deviation of each data value from the mean. Then they calculate the mean of these distances to find the mean absolute deviation, or MAD. The MAD represents the average distance of the data values from the mean of the data set. Finally, students think about how to choose the most appropriate measures to describe a data set. For example, to decide whether the mean or median better represents a typical value, they think about the shape of the distribution. When data is very asymmetric or has a few extreme values, the value of the mean is affected. For these data sets, the median might be more appropriate for describing the data. Students also begin to see how they can use statistics to support an argument. For example, to show which of two basketball players is better, they could use a measure of center to identify the player who typically scores more points. Or they could use a measure of variability to identify the more consistent player. Throughout this unit, it's important to focus on students' conceptual understanding of measures of center and variability. and how these measures summarize data to help answer statistical questions.